Okay, so we start the discussion on where we left yesterday, that is about the nutrients. In the nutrients that I was also explaining you about what are the different types of nutrients and what are their implications, like eutrophication that I discussed with you. Now, as you can see, these nutrients this can be coming from both the nutrients. If you just write like this, nutrients come from different sources, like organic, or say biochemical sources, and also inorganic sources. Inorganic sources, right? In this organic or biochemical sources that we can explain, so is something like, you see, the mostly this the nutrients many of the nutrients, like specifically carbon, nitrogen, you would require, say, you'd find, we will not consider hydrogen as such because it is a constituent from the water. So carbon, nitrogen, we can find phosphorus also from this, and this there are many other sources as well. This is organic sources, mostly you will find some of this calcium, magnesium as well, but generally what we can see is essentially these nutrients, these are specifically obtained from the organic sources, carbon and nitrogen, phosphorus as well. To a certain extent, phosphorus we can find out from different other sources, from organic or biochemical sources. So I make a distinction here by saying this, when I say the inorganic sources are essentially the sources, like coming from the inorganic sources. So you can treat this is organic or biochemical sources. Inorganic sources, as you can see, mostly from the salts. All kind of salts can result into, say, this typical kinds of salts, all kind of salts, as this bicarbonates, carbonates, phosphates, sulfides, sulfates. All this would provide inorganic sources, where also we will get a number of important constituents, like iron, manganese, then boron, cobalt, etc. Now, why I have been saying this is, is essentially to understand that the nutrients have a great importance in environmental pollution and control. Essentially because the nutrients completely disturb the balance, the natural typical balance that we generally observe. Say in such cases, like if you just observe that if there is a water body, say having water body having sources from, think of sources coming from different areas, like if this is a water body, we find this, just to consider that these are the conduits which are actually working as sources for this water. You can see this, what happens finally is, if the particularly the nutrients that are necessary for the algal growth, you will observe that the algae related, say, plants should begin to grow more than the others. That is what I have said. Say this is particularly you will observe, I mean, if you just observe few things, like to give you a very good example, you just go and observe in a particularly, see this algal growth or vegetative growth. Sometimes you can also say it as vegetative growth, increase vegetative growth, increased vegetative growth. What essentially it does is, so what where you can see, particularly for your simple typical example, if you just go to a near a place of an eatery, or eatery, in a particular to in a restaurant place or something, if you watch the water, I mean, water is being logged at one place, the water that has, that has been naturally stored for some reason at one place, you will find that the water is thick. What it is essentially thick, it looks greenish, and this is because of one reason, that the water that is being supplied from the sludges from the restaurant or sludges from the hotel, they are highly rich in nutrient. This nutrient is sufficient to increase, this nutrient makes a particular population of algae, a particular population of vegetation to grow very rapidly in the water. And as it is taking place, as I have said, this would finally lead to all this situation, finally lead to what we have, see, eutrophication. We have discussed about eutrophication. This has been a very important aspect of planning for water pollution control. The reason is this, there are many things like this, not only that I have said a source like restaurant, there are many kinds of, in agricultural production also nowadays. In agricultural production, we are adding number of a huge amount of fertilizers. To tell you one thing, just because in many cases we do not know how much the plants would require as fertilizer, and similarly in all countries, since the fertilizer is subsidized, so people generally tend to overuse the fertilizer, and this fertilizer, unused fertilizer, they mostly don't, many of them are highly soluble in water. Whenever you come in contact with water, they are sufficiently soluble. If they are soluble, they would finally which would finally lead to some water pond or water sources, so or rivers, streams, like that. So what is happening is there is a considerable degree, of increase in nutrients in the streams, lakes, water bodies, and things like that. As a result of which, this kind of eutrophication is a very common phenomenon nowadays. You go to any construction site, you go to any as I have said, near any factory, particularly in a sewage treatment plant, near a sewage treatment plant, or near any other aspect, any other areas where there is a sufficient discharge of nutrients. These nutrients, as I have said, this can be salt, say in a sugar plant or any other plant. This may be an organic source. In some cases, if they are using salt, a number of different kinds of salts are being used. In such cases, these salts should add to the growth of the nutrients, add to the increase in the nutrients, and this increase in the nutrients would finally lead to the increase of the algal growth, algal bloom that I have said, and would finally lead to eutrophication. So nutrients, this is what is of a significant importance as such. Well, I mean, as to say, another important thing is to say, observe here is about these nutrients. We will come back about these nutrients little bit in a differently related work, in a related area. But another important thing is many of these nutrients when absorbed by a living organism, many of the nutrients when absorbed by a living organism might lead to the lack of absorption, lack of absorption of another essential nutrient. This is very important also at the same time. Many of the nutrients when absorbed by a living organism, I mean much of the nutrients when it is being absorbed by a living organism might lead to the lack of absorption of certain essential nutrients. So, if you are increasing, if the body, a particular organism, if it is accumulating iron from the water, if it is accumulating iron from a source, it might reduce the intake of calcium or magnesium. So, not only that, you would be one organism might suffer from the increase added intake of a particular substance, like the substance like iron, an element like iron, but it would also suffer due to the lack of intake of other essential nutrients. So, this makes another important thing. This is so controlling the discharge of nutrients in the water bodies is one planning parameter for environmental pollution and control. So, essentially, if you are trying to keep your water regime, the source of water to be good, I mean the source of water to be drinkable or available for right use, you need to also control the discharge of nutrients in the water bodies. This remains as one important area of environmental pollution control. That is, not only that all nutrients are not sufficiently, nutrients when taken, when it is available in the right proportion in the water, it is good for our use. It is good for the use for many microorganisms, organisms as well. But when it is high, when it is very high in water, what it would do is it would only support the growth of a certain kind of organisms, either the plants or animal cells, that might lead to situations like algal bloom, that might lead also to the situation like eutrophication. Okay. So, apart from that, there are generally increase in the nutrient in water does not have a consequence which is can be related like a very serious consequences, but it can have nagging problems. Like in certain surroundings where high iron is available in the water. High iron. This can lead to digestive disorders. In many cities, you will find in the households, people install desulfurization, deironization plant, where the iron is, the concentration of iron is reduced. So, this is increase in the iron, in higher doses of iron does not lead to any kind of fatal diseases fatal diseases or contamination. But might lead to nagging problems, nagging health problems, and essentially affecting a large population. A large population may be affected. For most of the nutrients that we know, if there is an increase in the concentration of nutrients, it does not cause to any kind of serious health disorder, but it can have a nagging health disorder, like the disorders like that would continue to remain with the physiological system for a long time without actually leading to any event like fatality or things like that. Okay, so this is where what is the nutrient is important. Only one thing is particularly nitrogen, the concentration of nitrogen at some point, concentration of nitrogen in some point in water might lead to some typical type of health problems. Now let me explain that. This is the typical type of health problems that we generally observe is, you see, high nitrogen, you see nitrogen in water is available only in ammoniacal form. So it would be essentially it would be available as a mostly like a something like a radical, which is NH4. It would be generally available as NH4. So as you can see, this ligand as such is this particular ligand. If you just observe now, this NH4 in a particular situation in water, this can finally leads to this is NO3, and this can lead to this is lead to NO2 minus, and this would finally lead to NO3. So nitrite, it would be a nitrite ion first, this would be a nitrate. Now this nitrate, if it is available in the water, and if it is drank by a sufficient quantity by any child of below 6 years of age, this their body physiological system being somewhat fragile till that point of time, this would lead to this nitrite has a very high affinity to hemoglobin. Is very high, has a very high affinity to hemoglobin. Very high affinity to hemoglobin. This high hemoglobin, this high when the body in the body of a child, when the body essentially body of a child begins to accept or has accumulated a good amount of nitrite in its hemoglobin, this can lead to a particularly a disease which is known as the blue coloring. Is generally leads to the body color of the children. Body color of the children turns blue. Body color of the children turns blue. This particular disease is known as methemoglobinemia. Globini, METHEMOGLOBENINIMIA. This disease, as you can see, which would lead to reduction in the oxygen in the blood, can be fatal. Generally the children below the age of 6 years, below the age of 6 years are susceptible to this kind of diseases. So, it is very important particularly for the children below 6 years of age to see that the water that they drink contains very little concentration of nitrates, and essentially the nitrates are essentially where the sources of nitrates. Essentially they try to understand this. There are two important elements that construct our body, two very important elements that construct our body, and that has a very serious significance with water pollution. One of them is certainly carbon, that this is carbon forming carbon and water forming the basic hydrocarbon, and from that basic hydrocarbon only other hydrocarbons form, other hydrocarbons which are generally help us in the construction of the body. There is another substance which is very important for the growth of the body, for the sustenance of the body, the physiological growth, that is is nitrogen. The nitrogen that that helps us in the formation of the amino acids, the proteins that the form from the amino acids only the proteins begin to form. So these proteins are absolutely essential for our body. So whenever body decomposes, firstly the carbohydrates containing lack of nitrogen would begin to be decomposed. After a certain time, bodies the concentrating the features of the body containing the proteins and the other amino acids would begin to decompose. When these begin to decompose, in the state of decompose, if the water would be enriched with substances like substances containing nitrogen, and in such cases the nitrogen may be at point of time may be enriched with nitrite. When the nitrite would form, when the concentration of oxygen in the water would deplete, the concentration, the situation is concentration of oxygen in the water has decreased and the nitrogenous substance has increased. In such a cases, we will find higher incidence of nitrates in the water. This water enriched with nitrite can lead to a fatal disease like the blue coloring disease that we generally known as, or the methanoglobinea that we have discussed, it can form. So, but this is just to say this is a disease for the children only, mostly the adults are not affected by it. But a child when he crosses the age of 6, the danger of this kind of diseases almost goes away. But till that time, I know of one patient who, a particular child who suffered. In such a case, the only remedial measure is to keep the child continuously for 6 to 7 days under heavy intensity light, so that the body can recoup. So the body can begin to form oxygen, the concentration of oxygen also increases in the body, and as a result of that the effect begins to, by that time the nitrogen comes out of the body and the oxygen gets assimilated. So the normal respiratory function, normal physiological functions begin to take place. Okay. So this is the role of nutrients. This is why the nutrients are, when it is in a sufficient or sufficient concentration, they are extremely useful for us, because in the water, if it is the water is without nutrients, the water is of no use to us. Essentially, because for our physiological construction, many of the elements actually we derive from water. So water needs to be that is why distilled water is of no use to us. So the water has to have some nutrients, but when these nutrients increase the threshold, increase a particular, their concentration begins to increase and increase. In such cases, the nutrients can be essentially a huge problem. Okay. In the related term, says, if we just observe this, that there's particularly the salts. almost related to nutrients. In many of the nutrients, I think to differentiate all this is that most of the salts, many of the salts are nutrients, but not all nutrients are salts. Okay, just to make a distinction, there is, as I have explained also in the case like nutrients, many of those nutrients may be, the source may be a salt, but not all nutrients are salts. There may be nutrients may be of other varieties also. The nutrients may be, as I have said, the nutrients are not necessarily, say, the many hydrocarbons are essentially nutrients. Many hydrocarbons are also nutrients. So, is this all of them are some of them are salt, but not all of them are not all salts are essentially nutrients. We have this, particularly the salts that we have generally discussed about is, this is the sodium, calcium, the common calcium, magnesium, potassium are the common varieties of salt. Common varieties of salts, right? They are the typical common variety of salt elements, you can write. They are not necessarily, they are in the form of salts. So, you find sodium chloride, you can find, sodium phosphate, you might find sodium carbonate. So, similarly calcium phosphate, calcium carbonate, whichever are generally dissolvable in water and in the form of a salt will be available in the water. They has to dissolve in water and should be in the form of the typical salt species like the carbonates, bicarbonates, sulfite, sulfate, and you can name almost anything. There will be huge variety of salts that are essentially available. So, as having said all this, this calcium, right, with this basically is, we generally term then in a typical term, concentration of salts, concentration of salts in water, when in many cases salts in water, where they contribute to two things. One is the TDS, which is dissolved portion of the salts, another is TSS, the undissolved portion of the salt. There may be many salts which are undissolved. So, if this is below the saturation value in water, they would remain suspended, they would remain floating, they would be essentially available in the form of suspended form. So, this it is suspended TSS, this is about TDS. So, as we have discussed earlier in the classes also, this TSS is a of essentially of related to water aesthetics, like the typical term that we know is turbidity, related to water related aesthetics, like which cannot be used. So, the certain kind of also various parts industrial use also, and related to not only aesthetics value also of industrial use, but this suspended and also is industrial use. Industrial or domestic use. If the water is high TSS, you can there in some cases it might be allowed to want to take bath on that, with that water, but certainly you would not be allowed to drink the water. Okay. So, when you are going to a pond and taking a bath, even at high TSS you might be taking bath, but you are not generally supposed to drink that water. Okay. So, this is the different distinction it makes. Similarly, here in case of TDS, as I have said, TDS is essentially a quality parameter. Is essentially a quality parameter for both for drinking water purposes, drinking water, industrial use, etc. Industrial, you can say here in the TSS part, you can also write down another use of that is recreational use. You might concentrate, particularly if it is a natural pond or a natural water body, you might not be very concerned about the TSS in that water, but if you are just if you are using the same water for say a water park or things like that, there you may be interested in TDS also. So, in recreational purposes also, the water, this TDS may be important, recreational purpose. So, TDS is essentially a quality parameter. Also related to TDS is the tolerant level. So, tolerant level is every species, both in the plant kingdom as well as in the animal kingdom, if you just see that they have a certain tolerance to the TDS. Say if you are just to observe this is something, the tolerance is like this. If you have a glass of water, if you are dissolving one spoonful, a small spoonful of salt, you might still take the water. Okay, maybe of with some lemon and things like that, that may be a good drinking water. You would like the water to drink, but if you are adding 2 spoons, you cannot tolerate it anymore. So, in such cases, this is just to about having taste, but the physiological need also depends on the tolerance. So, not all organisms, not all plant species or not all animal species have similar tolerance level. They have different kind of tolerance level as well. That is where we just like to have a particular level, or we try to understand the TDS, total dissolved solids, in a more comprehensive manner, where we generally try to say is we have characterized, say in terms of TDS, we have characterized fresh water to have say about 1500 milligram per liter, fresh water, brackish water, to have up to 5000 milligram per liter, and you see this saline water, that is this is brackish water. Saline water is more than 5000 milligram per liter, and also that we know of the sea water, that is sea water contains about 30,000 milligram per liter. Seawater would have about will have about say 30,000 to 34,000 milligram per liter. Similarly, at the same level, if you just see that, mostly this is tolerance levels, identified tolerance level, for most of, say, poultry, if you are using the water for poultry, this should not have more than this concentration. This is pigsty, where the pigs are generally kept 4290 milligram per liter, and this is in a if it is, and crops, the crops between crops is depending on the different varieties of crop, we generally have identified tolerance level is about 500 milligram to 1500 milligram per liter, depending on different types of crops. So you can see if the TDS is more than this, so in such cases the water would be mostly unusable for our purposes, and so most of this is for irrigation, general irrigation, the tolerance level accepted or the tolerance level generally followed is this: irrigation about 2100 milligram per liter. So this is the typical concentration of TDS or the salt in water. This salt is, remember, when we say the salt here is not necessarily a single typical type of salt. A single salt would not mean necessarily NaCl, sodium chloride, or common salts like that. Is basically a combination of different salts, which are of importance. In some of these salts, we would also discuss the salts of certain heavy metals. We will discuss in a different in the class now, and we can see, before we move on to this, we would also say these thermal pollutants. High without dealing with the chemical nature of the discharge substances, without dealing with the chemical nature of the discharge substances, the temperature of discharge itself has great pollution potential. The temperature of discharge itself has great pollution potential. We are not merely discussing about the chemical nature of the discharge, except that if the mere temperature has a significant impact. Temperature has double impact. In fact, the temperature is one important thing about temperature is that this, if you just observe that particularly in a case like this, if you just observe in a case like this, here you can see, if in a body of water, if it is the a particular discharge is taking place, in a body of water like this, what happens is this is, just say if it is T, say Ti, this Ti being, it has a temperature here, a normal temperature, say temperature of say between say 10 to 20 25 degrees, say 10 to 20 degrees centigrade, and if you are discharging a certain substance, a certain mass of substance of say about having say 1000 degrees centigrade or say 700 degrees centigrade, like this. In such cases, what we observe here is that two things take place. As the temperature increases, as this temperature begins to increase, it begins to go up. Here two things take place. One is higher temperature leads to higher metabolism of the species available in water. This can also, substances for this plant species, small plants. This higher temperature would lead to higher metabolism. This at high temperature, the metabolism rate of the species available in water begin to increase. So the two phenomena, this higher metabolism means higher intake of oxygen, and as a result of that, and so this would be, the oxygen depletion would be at a faster rate, higher rate of oxygen depletion, higher rate of oxygen depletion, this is number one reason. If you just see, there are second reason here. If you just observe the second reason, that higher rate of oxygen depletion it would take place, and as also on the other hand, higher temperature would reduce the solubility of oxygen in water. So would reduce the solubility of oxygen in water. Okay. So the oxygen, which is generally feebly dissolvable, as we have explained, this oxygen would be further depleted. So there are two impacts that we can observe from these thermal pollutants, which can result into a very damaging effect on the species present in the water. So you can see now these two things add to the further to the difficulties present in water. So this is about the thermal pollutants. There are this is just to explain about the nature by which these thermal pollutants can impact. Essentially, as you can see, that this also, you can also write down another important thing here is there is the thermal pollutants. Thermal pollutants also increases reactivity of certain elements. This reactivity of certain elements by means of increased solubility. So you can see that the substances which are not soluble at that temperature would now be soluble. So, the solubility of other nutrients, other substances would increase in water. That would also have an effect on the reduction of oxygen. So, this is what, in irrespective of what the chemical constituents of the water, we can still observe that these thermal pollutants can have similar, different kinds of effects in addition to other toxic effects they might inherently have, right, like a highly discharged, say in a coke oven effluent. A coke oven effluent, when it is discharged, if it is not treated, when it is discharged, maybe the temperature is at about say 1000 degrees centigrade or 900 degrees centigrade, and still having a lot of phenol in it. The phenol itself is another damaging pollutant, but this would give rise to the sheer increase in temperature would also have a more serious implication. Now, having gone from there, the next pollutants that we would be using thermal pollutants. Except for thermal pollutants, we will come back to another very important aspect of our discussion, for particularly related to engineering sciences generally, except civil and sewage waste kind of situation. Here it is the heavy metals. Heavy metals. The heavy metals, as you know, these heavy metals are generally known as which has a specific gravity. The specific gravity more than 4 or 5. There is no essential distinction about one being a heavy metal, another not being when one can clearly demarcate one as a heavy metal, another as not, but generally for our purposes we will find that the specific gravity, if a particular specific gravity of a certain metal is more than 4 or 5, this would be generally termed as heavy metals. The typical heavy metals that we will be mostly discussed is, there's many of them which are basically highly toxic: aluminum, arsenic, nickel, copper, cadmium, chromium, nickel, cadmium, chromium, strontium, thallium, titanium, Ti, etc. Strontium, thallium, titanium, etc. These are known as heavy metals. But remember, another very important thing here. Another very important thing here is that not always heavy metal species are important. Heavy metals are not always the heavy metal itself is very pollutant. Like in such cases like chromium 3, chromium having valency 3, chromium having valency 6. This is called hexavalent chromium. This is called trivalent chromium. This is called trivalent chromium. So, of these two species, one of them is extremely toxic, whether the other one is not, whereas the other one is not. So, in such cases we find that in most cases a trivalent chromium would be toxic. I think this one is the toxic one. I will again in a different class I will discuss about this, but just to know about at this point of time, of these two species, one of them is extremely toxic, while the other is extremely non-reactive in nature. One of them is toxic, another is non-reactive. So, it's not always that a heavy metal itself is always a pollutant, but a heavy metal can be toxic, but there are certain species of many heavy metals which are essentially highly toxic. we'll briefly stop for about few minutes, 2 to 3 minutes, then we will begin to the next class where we will again start right about discussing about this heavy metals. Okay. All right, we will begin. I mean, I think the thing is, we have a little more thing to say about the water pollutants. We will continue by that, but anyway, to start with this, let me make a correction here, that this one is not the toxic one. This one is toxic. This one is toxic, and also in this part here I have not included two very important heavy pollutant, a heavy metal pollutant, like this. One is mercury, one is essentially mercury, which is also a heavy metal contaminant, and also another is lead. So the lead. So this mercury and lead, please include them. These two are important metals. These two are very important heavy metals, which are toxic to many of them are known as toxic to human body or toxic to any other kind of organisms. Like, I will just explain you a case study here, or also similar to this is this, if you can see this. Okay. Now, what happens in such cases of mostly, in cases of heavy metals, many of the heavy metals are toxic, which has they are identified as identified toxins. These are identified toxins that they can relate to nephrotoxins, no longer required in big industrial plants where they extract gold. Non-mercury gold extraction processes are becoming more and more common, but in small practices and small uses, mercury still remains a very important substance which is generally used for extraction of gold. One of that such situation is is a typical case where you have seen in many cases in India also you have seen that there's poor people by the river side, they generally use pans for gold panning, for to collect nuggets of gold that are generally done. But this is particularly true particularly very common in Brazilian Amazon streams, where after Brazilian Amazon streams, where this kind of mining is very common. This kind of mining is very common. What is done is, generally is the methyl mercury is used for amalgamation of the gold particles. Methyl mercury for amalgamation of the gold particles are generally used, right. Now, this methyl mercury mostly about 5 to 10% is used of the concentration that is generally used for the purpose of amalgamation of the gold particles. Only 5 to 10% are used, which form a bonding with the gold particles. 1,2-dichloroethane. What is their specialty? Specialty is they are volatile. They are volatile in STP, standard temperature pressure. That is why they derive a name of volatile organic compounds. Volatile organic compounds. They are essentially organic in nature, but as you can see, they may have say this they may have the halides in them. They may have say different types of chlorinated substances. They might have any other substances, organics. They might also have some organics in some cases. So this can be they can have certain metallics also in that. So specialty is that they are volatile in standard temperature pressure. That is very important. What are those? Cleaning agents. Cleaning agents. Many cleaning agents are basically these volatile organic compounds. There is perfumes, sprays, and they are and many of them are known as carcinogens. Many of them are known as carcinogens or mutagens. Carcinogens or mutagens. Carcinogens or mutagens. What is this mutagens all about? The mutagens are, these mutagens may be not leading to carcinogen, but not generally leading to carcinoma or cancer, but they can also have local changes, local abruptive changes. It can take place. Local abruptive changes they can take place. So usual phenomena, particularly of this, apart from being carcinogens themselves, they cause nausea. This is the vomiting tendencies. This is nausea, the vomiting tendency.